Morning, Ashton. This is your math lesson for Monday. I'm on page 138 in your math book. We're starting a new module today called Ratios and Rates. So if you look on page 137, you'll get a little bit of a preview of what that sort of means. And you might have seen some things like this before. And so here's the first example that we have here. Okay. It says, the cafeteria at Frost Middle School is being painted sky blue. The table shows the amounts of bright blue paint that must be mixed with different amounts of white paint to make sky blue paint. Use number patterns to complete the table and answer the question. So if they were mixing this kind of paint, they would, if you were using 2 gallons of bright blue paint, you would have to use 3 gallons of white paint to get this color that they want up here. Okay, so 2 gallons of bright blue, 3 gallons of white. Now, if you look at the table, if we had to try to guess what this next number is based on what these two, what this ratio is here, 2 to 3 is the ratio. We call that a ratio. It's like a comparison. It might be not too apparent what number goes here next, but if we look at the pattern in a different way by going across, then you might start to see some different patterns. So here, 2, 4, blank, 8, 10. Well, we know from our work with counting and numbers, just basic number sense, we know that 2, 4, 6, 8, 10 are the first 5 even numbers. Now, if we go down here, we're skip counting by 2s in that first row. If we go down to this next row, we have 3, blank, 9, 12, blank. Now, these are not odd numbers, but they are skip counting by multiples of, okay, you can see the missing number here would be 3, 6, 9, 12, 15. So basically what we've done here is we've created ratios of these two numbers. So if you had 2 blue gallons and 3 white gallons, that would be the same as if you had 6 blue gallons and 9 white gallons. Okay, so these are almost kind of like equivalent fractions. They're at the same rate of amount per color. So if you sort of think of this like equivalent fractions, then you're thinking about this in the correct way. Okay. So it says the painting crew needs 40 gallons of sky blue paint for the cafeteria. What amounts of bright blue paint and white paint should they mix? Okay. So they need 40 gallons of sky blue. So one way to think about this is when you combine these 2 gallon amounts here, you get 5. When you combine these two, you get 10. Combining these two, you get 15, 20, 25. Okay, so if our chart continued, then we would we're looking for which combination of those paints would give us 40 gallons. Okay, so one way to think about that is, well, the table doesn't go up to that high, but if you look at this one right here, right? When you do 8 gallons of blue paint, 12 gallons of white paint, that equaled 20 gallons total, right? So if you double 20, you get 40, right? So if you double both of these amounts, 8 times 2 would be 16, and 12 times 2 would be 24. Now if you add those together, that will give you the 40 gallons that you need. So this ratio here, 16 over 24, would be following the same pattern as these other amounts here. So we would need 16 gallons of bright blue paint and 24 gallons of white paint. And then you'd be able to get the right mixture and the perfect color of that paint. Okay? So that's just a little introduction as to what we're doing in this upcoming module. All right? Now, if you flip your page in your math book, you're going to see the page titled, Are You Ready? On page 138. I did a couple of examples here that I want you just to, oh no, let's see. Sorry. So this is the page that you're going to be doing, Are You Ready here? I just did a couple of examples on this page because I want you just to make sure that you felt comfortable doing these types of comparisons before you get started. So if we were making equivalent fractions, what we just mentioned on the previous page, you know, I'm not sure exactly how much experience you have with these, Ashton, but I'm kind of basing this on the fact that you have seen these before and this isn't new information to you. But just in case your brain needs a refresher, let's just remind ourselves. Okay, if we're looking for an equivalent fraction of 3/4 that has a denominator of 24, we would want to take 4 times something to equal 24. And whenever I multiply times the bottom, I also have to multiply times the top. So 4 times what is 24? That would be 6, right? And then 3 times 6 is 18. So 18/24 is my equivalent fraction. Okay? Over here in the next example, if I had 11 over 33, 11 times something is 22. So therefore 33 times something is going to give me my denominator. I know 11 times 2 is 22. So I had to multiply 33 times 2, and I would get 66. Okay? Over here, 4/5, 5 times something is 45, so 4 times something will give me my numerator. 5 times 9 is 45, 4 times 9 is 36. And lastly, 2/3 is equal to 18 over something. Well, 2 times 9 is 18, so 3 times 9 is 27. Okay, so that's going to be like the first types of questions that you're answering on the next page. Then there's a couple more questions regarding patterns. So figuring out what the rule to a pattern is and trying to figure out what comes next in that pattern are for questions number 7, 8, and 9. Okay, and then finally to wrap up, towards the bottom of the page, we have some different different practice questions for dividing decimals, which we're just coming off of. So just as a quick reminder, for number 10, if we have 11 and 6/10 and we're dividing by 4, okay, since there's no decimal on the outside, you can just go right ahead and move that decimal point up. And 4 goes into 11 2 times, minus 8, 3, and then 6, and 4 times 9 is 36 with no remainder, so our answer is 2.9. Okay? So I kind of gave you the answer to that one, but that's okay. And then for number 11, I'm going to give you another answer here, just so you can sort of see and be refreshed on how to do this. If it's 48 divided by 0 and 6/10, okay, don't forget, oops, I'll just move that over. Don't forget to move your decimal point over one place, and since in this number there is no decimal, we just know that the decimal point is at the end of that number, so we're going to move that over a place, which would give you a 0 there. So that would be like our new problem of 480 divided by 6, which will come out even as 80. Okay? So there's a couple of examples for the decimal division, and the rest of the questions regarding fractions, all on page 138. That's all you have for today, Ashton, for math. So just a nice quick lesson to get you started for the week. And don't forget to submit that to me so I can see the evidence of your work. Okay? And then tomorrow we're going to get started with a brand new lesson on ratios. Okay? All right. Have a good day, Ashton. We'll see you again soon.